The last thing that we are going to look at here is how to fix this synchronization problem that we had talked about. So if you remember, with synchronization problems, what could happen is that we might have two or more threads trying to manipulate an object at the same time, and because of that they could end up corrupting the data because they might be stomping on each other or interfering with each other and not leaving the data in a valid state. And that's because all these operations aren't atomic. What we had talked about was if you had a number that was being stored in a variable and you try to increment it in one thread and decrement it in the other thread, it might actually end up doing the wrong thing, because in between those states it could have one thread could have gotten it while the other thread was in that method trying to increment it. So one way that we can prevent this in Java is we can use our synchronization, or we can declare one method to be synchronized. And there's a few other ways that we can do this, but I want to show you the most basic example just so that you can understand how to alleviate these problems kind of at a high level. And if you need to get more detailed versions of this, there definitely are some more out there, but this will get you some basic understanding and some basic ability to be able to accomplish this. In this example, we were basically running this continuous printer thread, and in this continuous printer we are calling this print using counterage method on our printer. Now if I go into our print using counterage, we can see that multiple threads could be or would be entering this at one time, and in this example it is not a problem because we are not doing anything with the internal state of the printer. So we are not going to really see any issue here, but just so to demonstrate this concept, let's see how these threads are interacting with this method right now. So I'm going to print every time that we enter this. I'm going to print entered, and then I'm going to print out the actual ID of the thread. So we are going to do this thread dot current thread, and then we are going to say get ID, and that just gives you the ID of a thread. All threads have their own unique ID, so I'm going to do the same thing when we exit this method. So we are going to call this println, and we are going to print exited right here. So what's going to happen is every time a thread comes into this method and calls it, we are going to get an entered, and we are going to get the message, then we are going to get exited. So if we look at what's going on here, I have got a thread pool set up. I set it up to 100, so all these threads are going to be running at one time. And let's run this and see what the results looks like. So you can see here, I'm going to scroll all the way up to the top, and we have got thread 13 entering, and then we have thread 10 entering, we have thread 12 entering, we have thread 11 entering, and then 11 has finally exited. It actually exited before 10, and then 14 entered, and then 13 exited. So we have all these threads entering and exiting at different times. A lot of threads are entering before the other ones exit, and any time that happens, it is a potential for a problem here, because it could be manipulating data, and we might be expecting that everything in that method is operating as an atomic operation or as one. We don't want it to be interrupted, especially if it is operating on some internal data for the printer. Let's say it was changing a page count or doing something with the printer, and it was setting its state. By having all these threads entering here, they could be entering at different points where that data is not in a constant shape, or it might be corrupted by having all these threads enter. So we can solve this problem really easily in Java, and all we have to do is go into our printer class, and we are going to change this. So this method is going to use synchronized. So now we just declare this as synchronized, and this keyword in Java will make sure that only one thread can enter at a time. So all the other threads are going to block here, waiting while one thread enters and goes through this. Now if we run this, you can see how this is actually working. So I'm going to scroll up to the top here again, and you can see here we are getting thread 10 enters, thread 10 exits, thread 12 enters, thread 12 exits, thread 12 enters, thread 12 exits. So threads are not interleaving here between this method. So multiple threads can't actually get into this method until the previous thread has gotten out. So that is the basic example here of using synchronize, and this is very useful whenever you have a method that you know is going to be accessed by multiple threads and it is manipulating some data. You need to use a synchronize call or somehow to synchronize it so that multiple threads aren't interacting with that data or calling that method at the same time.